Welcome to another video. In this video, I'm going to solve this question, which is question number 11 part B from BHSEC 2022 section B mathematics paper. Okay, the question says find the coordinates of the vertex, focus, equation of the directrix and length of the lattice rectum of the conic section x squared minus 4x minus 8y plus 4 equals to 0. So we are given with this equation now. Given by looking at the equation, you can get few information. Okay, if you observe very carefully here, you know that the highest degree of this polynomial is 2. Okay, and this degree is on only x variable, which is only on one variable, whereas our y variable, which is another variable, has the degree of 1. So if this is the case, then this equation will describe the conic section, that is the parabola. Otherwise, for ellipse and hyperbola, you have to have both of the variable having the highest degree 2, which means you have to have x squared and y squared. Okay, so if it is for ellipse and hyperbola, then you have to account for the eccentricity value and also the intercept form to undermine the conic section. But for this, we are confirmed that this is the equation of the parabola. And if you see very carefully, if you write in this way, x squared minus 4x plus 4 equals to 8y, right, which will be just y equals to 1 over 8x squared minus 1 over 2x plus half of this one. Okay, I have divided this throughout by 8. Then you can see that this equation is exactly in the form y equals to ax squared plus bx plus c. So from this also, it can be obvious that the equation describes the parabola. And if you see this very carefully, this a value is greater than 0, right? Which is positive, which means that this parabola will be right-handed or upward parabola. Since you know that our variable x has the degree of 2, which means that this equation will be now our upward parabola. Okay, so if this has something like y squared, x equals to something y squared, value of a is greater than 1, then it should describe the right-handed parabola. So these are the basic information that you have to know. Therefore, to find the coordinates of vertex, equation of directrix and the length of lattice rectum, now we have to change this to some format which we have learned in the conic section. Okay, now we have that the general equation of parabola, upward parabola, okay, parabola with vertex shifted to coordinates h and k, okay, is written as x minus h the whole squared minus 4a y minus k equals to 0. Okay, it can also describe the downward parabola. Okay, now for this upward and downward, now it will depend on the sign of this a, which is the distance between the vertex and the focus. Okay, now we have to modify this equation in such a way that it resembles this. Okay, now we have that here, if you see very carefully, we can write this like this: x squared minus 4x plus 4 equals to positive 8y. Okay, and if you see this very carefully, this is in the form a squared minus 2ab plus b squared, which can be written as a minus b the whole squared, right? If you see this very carefully, if x equals to a, okay, so we have a squared minus 2, then we can write 2 then x, right, and 2 of squared to get this 4 like this. So if this is the case, then we can say this whole equation represents x minus 2 the whole squared equals to 8y. Actually, this square is already been completed. Okay, now if you see this very carefully, we can also write this as x minus 2 squared, If you bring this 8y here, then it will get 8y equals to 0, right? So it can be also written as x minus 2 squared minus 8y minus 0 equals to 0. Okay, so if you see this very carefully, this equation exactly resembles this. Therefore, we have to say that x minus h squared equals to 4a y minus k, like this. So we can write this here. You can get x minus 2 the whole squared equals to, here is, if you go like this, then it will get 8y minus 0. So if you want to write exactly in this format, then we can also write as x minus 2 the whole squared equals to 4 times 2 times y minus of 0, right? So now with this you knew lots of information. From this you knew the value of h, you knew the value of k, you knew the value of a also. We can answer the first part of the question, which is the coordinates of vertex. Therefore, the coordinates of vertex hk, which is coordinate, okay, hk is just 2, 0. So this is our coordinates of the vertex, which means if you roughly sketch our parabola here like this, then our vertex is here 2, 0, which means 2, 0. And this equation is just x minus 2 squared equals to 8y, right? And then if you try to find this y-intercept, then you have to substitute x equals to 0. When you put this, you get 4 equals to 8y, which will be just y equals to half. So which means this one is just 0, 1/2. Okay. Now from here, our value of a is positive 2, which means that from the vertex we have to move 2 units upward, right? Positive 2 means to positive side of the y-axis, which means by moving this, if this is 1 unit, this is 2 unit, then our focus will be somewhere here, okay? And our y coordinates will be now 2, because the distance between the focus and the vertex is fixed, which is given by the value of a, and our value of a is plus 2, which means our this distance is just plus 2, and the x coordinate is here 2, so the focus is also 2, 2. Okay, and let me make this little bit longer and extend this parabola like that. Okay, so our equation of the focus is now 2. The coordinates, the focus is given by what? It's given by h and k plus a here, so it can be written as 2, and here our k value is 0 right here, plus this a value is plus 2, so it is just like that. And we knew the coordinates of the focus now. Now our third one is equation of the directrix. Now if you draw this line here passing through the focus and touching the curve here, and you say A and B, so this line AB is known as the lattice rectum of the parabola. Okay, but if you draw line which is opposite of this vertex but the same distance of this A from the vertex, then this line will be called the directrix. Therefore, from the vertex you went 2 units up to get the coordinates of the focus. Now to get the equation of the directrix, now you have to move 2 units down, which means in opposite direction to the focus, to get the equation of the directrix. Let this be 1, negative 2. You have to move 1, 2 units, negative 2 units downward, which means our directrix will lie here. Okay, so this is our directrix line and this is our lattice rectum. Therefore, the equation of this line will be y equals to negative 2 and y plus 2 equals to 0. Okay, therefore 3, the equation of directrix is, it will be given by y plus a equals to 0. This is general, right? So the equation is y plus 2 equals to 0, and this is the equation of the directrix. Now what is left? The last one is to find the length of the lattice rectum. To find the length of lattice rectum, we know that the length of lattice rectum is L equals to 4 times the absolute value of the, here the absolute value of A means you know that the distance between the vertex and the focus will be plus or minus A, because see, if this is the downward parabola, then your focus will lie here, somewhere here, and your A value will be negative, in negative version, right? Whatever may be, you have to just take the absolute value of A, which means you have to take the positive value here. Therefore our length will be 4 times of our A, which is plus 2, which is 8 units. Okay, so this is the length of the lattice rectum. Here the coordinates will be just 2AA, right? So here it is negative, so I will get negative of 4 and 2, and here positive of 4 and 2. Okay, because here the coordinates will be just 2a, a, and here negative 2a, a. For the further information, I will make detailed video on conic section deriving the equation for it, so you can check it out later. So with this, we have completed the question. Okay, now to find out whether you have done correct or wrong, you can just use the concept of the definition of eccentricity to derive the original equation. Okay, this one. So how will you do is that we know that the eccentricity of the conic section, which is the parabola, is exactly 1, right? Which means that from the definition of eccentricity, if we assume that this is the locus with xy, then the distance from the focus, which is pf, and the distance from this point to this directrix, okay, this we can say pd, is just equals to 1. We know that pf divided by pd is equals to e equals to 1, right? Which means that we can say pf equals to pd. Now for this distance, it is the distance between this point f and this point xy. Therefore, by distance formula, we have that the pf can be written as x minus 2, like this, whole squared, plus y minus of 2 whole squared, whole square root should be equals to this pd. Pd is the distance from this line, okay, this directrix, which is y plus 2 equals to 0, and the distance between the point this pxy, which means the perpendicular distance between the point P to the line x plus by plus cz plus d equals to 0 can be given by taking the modulus of the equation here and using the coefficient of this, which are the normal vectors here, which is a squared plus b squared plus c squared, something like that. But here our b squared is just 1 and other a squared, c squares are 0, right? So this one can be just the square root of 1, right? Which is 1 squared is always 1. So now we can square this, right, and get the original equation. See, when you square this, then you will get this as x squared minus 4x plus 4 plus y squared minus 4y plus 4 equals to, here is y squared plus 4y plus 4 here, like this. And if you see this very carefully here, our y squared will get cancelled and our 4 will get cancelled. Therefore, what is left now, which is x squared minus our 4x, then our 4, then here 4y and here 4y. So when you bring this here, it will become negative 4y. So total is negative 8y equals to 0. So if you see this very carefully, this equation and this equation is completely correct. which means your equation of the directrix, your coordinates of the focus is correct because you got the original equation by using the definition, which is the fundamental definition of the parabola, okay, in terms of the eccentricity, that you got this and your original equation same, which means your all answers are correct. With this, I come to end of this video. I hope you all would have enjoyed this video, really learned something, and enjoyed the beauty of the math. I'll see you in next video. Thanks for watching and supporting. Bye.